All right, let's pull back the curtain on something we all kind of take for granted, the hidden world of logistics. We're going to dive into the incredible science and strategy behind how basically everything you use, wear, or eat gets from point A to point B.
I mean, think about it. You click that Buy Now button and poof, a day later, sometimes just a few hours, a package is on your doorstep. Have you ever really stopped to wonder how that magic actually happens? How is that even possible?
Well, the secret is something called material handling systems. And no, we're not just talking about a couple of forklifts and a conveyor belt. Think bigger. This is like a high-stakes game of chess. It's this amazing mix of hardcore engineering, super smart data science, and yeah, even human psychology. The goal of the game? Move stuff as efficiently as humanly and robotically possible.
So, if it's a game, how do you keep score? Well, you've got to watch the numbers. These are the key performance indicators, or KPIs, and they are everything. We're talking about shaving seconds off every task, using every single square inch of a warehouse, and keeping costs and energy use way down. And the most important one, safety. You can't compromise on that. Every single decision is judged against these metrics.
Okay, so to really get our heads around all this, let's picture a massive, high-tech toolkit. The first tools we're going to pull out are the workhorses, the movers. These are the ones responsible for all the heavy lifting and covering the long distances inside a warehouse or factory.
And right away, you find that these movers fall into two big families. On one hand, you've got your continuous systems. The classic example is a conveyor belt. Just think of it like a non-stop highway for products. But on the other hand, you have discrete systems. This is where things get really cool with autonomous mobile robots, or AMRs. These guys are like the Ubers of the warehouse, flexible, smart, and moving on demand.
Now those AMRs are all the rage right now, and for good reason. But they come with a catch, a hidden cost that kind of sneaks up on you over time, something you might not even think about on day one.
And that challenge? It's battery degradation. Yep, the exact same thing that happens to your phone after a couple of years. The battery just doesn't hold a charge like it used to. And as research from folks like Molnar and his team shows, if you don't plan for this, you're in for a nasty surprise. A few years down the road, you might actually need a bigger robot fleet just to get the same amount of work done. It's this creeping cost that you absolutely have to model from the start.
This is why the smartest systems are now becoming energy aware. It's not just about finding the fastest route anymore. It's about finding the most energy-efficient one. These systems are constantly making trade-offs, balancing speed with power consumption, and optimizing for the entire life cycle of the robot, not just a single trip. Okay, back to our toolkit. We've got our movers to get things from A to B. But what happens when you get there? Now you need the specialists. You need the lifters and placers, the equipment that handles the delicate, high-precision work of picking things up and putting them down just right.
You know, when we talk about automation, it's so easy to fall into that black and white thinking of humans versus robots. But the reality on the ground is way more interesting. Often, the smartest and most practical solution is somewhere in the middle.
And a perfect example of this middle ground is something called teleoperation. Seriously, imagine you're sitting in a comfortable chair, maybe hundreds of miles away, holding what looks like a video game controller. But you're not playing a game. You're operating a real, heavy-duty forklift. It sounds like sci-fi, but research from Amio and others proved it's a real-world option by successfully handling a 300-kilogram pallet remotely.
And the benefits here are huge. You get much better precision thanks to smart control systems. You can keep your human operators safe and sound in an office while the machine works in a hazardous or uncomfortable place. And here's the kicker. It is often way cheaper to implement than a fully autonomous, no humans allowed system. It's a powerful hybrid approach.
Okay, so we've moved it, we've placed it, but where does it go? This brings us to the real brains of the operation. Let's reach back into our toolkit and pull out the organizers. This is all about the strategy of storage and identification, knowing where things live and how to find them in an instant.
And this is so critical. A warehouse isn't just a big box with a bunch of shelves. The strategy for how you assign items to locations, the storage policy, can have a more massive impact on efficiency than almost any other single factor. One of the most powerful strategies here is called dedicated storage relayout. Instead of just putting an item wherever there's an open spot, you assign a permanent, fixed home for each specific type of product. Then you organize the whole warehouse around that, putting the most popular items right up front where they're easy to get.
So what kind of a difference can a seemingly simple change in strategy make? How about a 76.6% improvement? Yeah, 76.6%. Now the big question is, an improvement of what?
Get this, that's the reduction in the total distance that workers and machines had to travel. In one case study, just by implementing this dedicated storage strategy, they cut the travel distance from over 40 kilometers, that's basically a marathon, down to under 10. That is a mind-blowing leap in efficiency, all from just rethinking the layout.
And of course, great organization needs great tracking. The next frontier here is to integrate identification technology like RFID directly into the robots. This means an AMR isn't just moving a box anymore. As it travels, it's constantly scanning inventory, doing a continuous stock take, and making sure the warehouse's digital brain is perfectly in sync with physical reality.
So, we have all these amazing tools in our toolkit. We've got movers, lifters, and organizers. This brings us to the final and maybe most important question. How do you choose the right combination for your specific job?
And this is where it gets really complex, because you're not just picking whatever has the lowest price tag. You have to balance all these factors that are often fighting against each other. Speed versus cost, flexibility versus raw throughput, full automation versus human ergonomics. It's a constant tug of war. To make a truly solid decision, you have to look at the whole picture. You have to consider the ergonomic impact on your workers. You've got to model the total energy use over the equipment's entire life, not just year one. And you have to think about the total life cycle cost, including how well it'll play with technologies you might buy 5 years from now. It's why experts use formal, multi-criteria decision methods to weigh all the pros and cons. We can model and simulate all of this on a computer to find the perfect solution, but, the real world always throws a curveball. Things like dust or temperature fluctuations, or just subtle human factors with operators, can change everything. That gap between the perfect simulation and the messy reality, that's where the real engineering happens. And that brings us to our final thought. We've seen technology solve for speed, for cost, for energy, but as these automated systems become more and more integrated into our workplaces, what's the next great challenge? What is the next human factor that we will need to understand, model, and optimize for? Answering that question, well, that's what's going to drive the future of this entire field.